This is metal wire. In fact, it's copper wire that we've wrapped around hundreds and hundreds of times. And we stuck both ends of the wire to this little LED in the end, you see, a little light bulb. Now, if we have a magnet, you see, and we place the magnet inside a conductive coil, it creates a magnetic field. And it makes little tiny things in there called electrons all go in the same direction. Now, when electrons go in the same direction, that's what we call electricity. So if Ivana gives it a little shake now, it should activate the electrons and produce enough energy to light the little LED at the end. With that, not magic, science. Now, here's another thing. If you've got your own energy source, and here we've got an energy cell, or battery, you see, and you've got a very strong magnet, and this is called a neodymium magnet, you see, and you place the magnet on the bottom, you place the fuel energy cell on top, then you get a bit of copper wire, and we bent this copper wire so it touches the top of the battery and it drags along the magnet at the bottom. Now what's going to happen is all the electrons or electricity is going to come out of the top of the battery into the copper wire, and it's going to create a magnetic field. Now this magnetic field is going to be different than the magnetic field produced by the magnet at the bottom, and something quite remarkable may happen. What do you think it is? Who knows? It's an experiment. Let's find out. Have you been playing with this, Ivana?
I didn't touch it, Professor.
Look at that. The world's most simple electric motor. You see it? Not magic, science. So, now I know what you're thinking. You're thinking, well, you know, it's kind of impressive, but it's not very dangerous, is it, your science show? Eh? Can't you be a bit more dangerous? They're saying. Well, yes, of course we can be dangerous. And this leads you on to the next bit, you see. We still use steam to make electricity, and at the moment we use fuels like oil or coal. These are fossil fuels that were actually plants millions and millions of years ago when the dinosaurs were around. You see, fossil fuels. Now when we burn fossil fuels, they release a lot of carbon dioxide, and plants can absorb it all at the rate we're using it, you see. So a lot of it goes into the atmosphere and heating up the valley planet, isn't it? You see? So some scientists tried to think of different ways of making some heat and light energy. And the way they found out to do this is rather controversial and dangerous. You see, mankind discovered that these very, very small things called atoms, of which electrons are part of, you see, when you can split an atom right down to its nucleus, or middle, you can produce nuclear power. A lot of heat and light energy is exchanged in the reaction. Very, very dangerous. So I thought, well, you know, why don't we make a very small nuclear explosion here to show you how it's done. Now, I know you're thinking, oh, you've already told us that nuclear science is very dangerous. Oh yeah, of course it is. But I'm going to take some precautions. I'm going to put on some gloves. I suggest you put some goggles on as well. Now, Ivana has been around the Eden project today looking for atoms. And she's found a couple of juicy atoms. She's put them in this little atom container, you see. Now what we're going to do, just one at a time, We had a bit of an accident last week. So if you just place an atom very gently on top of that anvil, and I'm standing away because I don't want to breathe on the atom, because they tend to roll off and fall on the floor, and it's very difficult to find. Now, let's have a look. Yeah, it's a good one. Right, okay. Now I'm going to use something that in scientific circles we call a kinetic accelerator. Or hammer, you see. And what we're going to do, we're going to get the atom, and I'm going to bash the atom really squarely until it splits down to its nucleus and hopefully creates a fair amount of heat and light energy. Right? Ready?
Ready, Professor.
Oh, I guess you're a little problem to steam. Yeah. Right! This gets a bit scary. Right, here we go. 1, 2, 3! Wow! Look at that! Amazing! Whoa! There we go, nuclear science. Now, it must be said that nuclear energy isn't all fun and games, you know. It produces a byproduct called radiation. Radiation, yes. And it's very, very dangerous to all living things and remains so for thousands and thousands of years. And we haven't really found an effective way of getting rid of it, have we? So it's probably not the best way that we can think of making electricity just now. It's getting safer, I'm sure, but still, we should be applying our hearts and our minds to more sustainable and greener ways of producing the power we need to energize us into this millennium